semicircular ring. Semicircular ring. Next concept is here. Semicircular ring. Carefully observe here. Semicircular ring is there. This semicircular is in a charged, continuously charged distribution on this the semicircular ring. Continuously charged distribution completely. Okay, students. Radius R. This is the radius R. Okay. Find the electric field intensity at O point. This is the center of this semicircle. Okay, students. O is here. When you find the electric field intensity at an O point due to this charge of the distribution body, how can you find it? So let us know here. First of all, we take here this similarly same as it is position. This is a, first of all, we take the very small elemental charge on this the charge distribution body. Okay, students. So from take at certain angle, at theta angle, we take the elemental charge. This is one of the very small elemental charge is here. Very small elemental charge. We take this dq. Take it at theta angle. From this theta angle, from this 0 to at theta angle, we take this elemental charge. Okay, students. Theta. From this theta angle, we take this elemental charge dq. This distance is very small dx. Okay, students. Clear all of you? And next, this angle, making angle, what is that here? D theta. So this is radius also is a R is. Due to this elemental charge, very small charges, due to this small charge, electric field intensity at the point radially outward, dE. dE. Okay. D, what is the angle making here? This is also the theta, this angle also is, what is that here? Theta is at O point. Is that here? O point. Electric field intensity due to this small charge, small electric field intensity is here, the radial outward dE. Okay, students. So dE is there. You observe carefully here. Okay. So this is you observe here. This dE is making theta angle. This dE electric field intensity is a, you observe here, this dE is a divided into two components. dE cos, this is a dE cos theta, dE cos theta, dE cos theta. Another one is a dE sin theta. This dE is a divided into two components, dE cos theta and dE sin theta. Similarly, same as it is mirror element. Another direction we take it, same mirror element we take here, same dq charge, and take here this ray length, take here this elemental, we observe carefully, elemental charge, we take this here, same elemental charge, and this is also is electric field intensity due to this element charge, dE is here. Okay, students, angle theta. Okay, this is also making these two components here, dE cos theta and dE sin theta. Yes or no? dE cos theta, dE sin theta. dE sin theta, dE sin theta is a cancels each other. Yes or no? dE sin dE cos theta, dE cos theta cancel. dE sin theta will be added. Okay, let's go easier due to this charge. dE cos theta will be cancelled each other due to elemental, due to why mirror element, but you observe carefully, but here dE cos sin theta will be added, so you observe dE cos theta here, dE cos theta, dE sin theta same direction, dE sin theta. So these both are cancelled. Like that, each element, you observe each element will be cancelled. dE cos theta is a cancel. dE sin theta will be added. So, but dE sin theta will be added. Okay, students, clear all of you. Next is here, you observe carefully here in this point here. d sin theta will be added. Okay, net electric field at that point due to this continuous charge distribution, E net is equal to integration d sin theta. d sin theta. From which point? What is the limits here? It's which point from the 0 degree to completely pi 180 degree. From 0 to completely 180 degree. So how can I write here 0 to pi? This is limits. So E net is equal to d sin theta. Okay, students here. So what is the dE is here? So now right now here. So that is E net is equal to, therefore right now E net is equal to integration of 0 to pi dE is equal to what is how? K d is K dQ by what is the distance? R square into sin theta. dE. dE, what is the meaning of the dE is here? Electric field intensity at this point. K dQ by R square due to this elemental charge electric field. Okay, students? So d K dQ by R square is sin theta is here. Okay. So K is a constant. Therefore, then E net is equal to, how can you find the E net is equal to? K is a constant removed from this integration. So 0 to pi, then you get what is a dQ by R square sin theta. Okay, students. And next now here, what is a dQ? Already we discussed it here. Let's now observe carefully. So already we discussed here this linear charge density. Linear charge density lambda is equal to, how can you write? dQ by dx. dQ by dx lambda. Then you find that dQ is equal to lambda dx. Lambda dx. So dQ is equal to lambda dx. So then dQ is equal to lambda dx, this distance. dx, what is the distance? dx distance. How can you get the dx distance? dx is equal to r, you know very well. dx distance is equal to this arc assumption, this is like that here. Okay, students? Like that, d theta is here, r, this is the dx. Okay, this is a r, radius this is a r, dx distance, d theta. We will find that dx is equal to r into d theta. Yes or no? Yes or no here? So like that here, dx is meaning r d theta. This dx dq value substitute in this equation, in this form. Then E net is equal to k integration of 0 to pi. dq is meaning lambda r d theta. Lambda r d theta by r square sin theta. Okay, student? So r get cancelled. So then you get here E net is equal to lambda is a constant, r is a constant, remove from this integration, k lambda by r integration of 0 to pi, what is that? Sin theta into d theta. Okay, students? Integration of sin theta into d theta. Then you find this here, E net is equal to k lambda by r, k lambda by r, integration of sin theta d theta. What is the integration of sin theta? Minus cos theta. Minus cos theta. What is the limits given? 0 to pi. What is the limits given? Is 0 to pi. So therefore E net is equal to k lambda by r, k lambda by upper limit minus lower limit. Upper limit, what is the value? Pi is given 180 degree and lower limit what is 0 degree. So right now here minus cos pi minus of cos theta while upper lower limit is 0. Okay, students? Observe carefully here, don't confuse. Upper limit minus of lower limit. Okay? Then you write is E net is equal to k lambda by r, k lambda by r cos pi cos 180 degree is equal to minus 1. Already minus is here. Minus cos 180 is equal to minus 1. Minus into minus plus. Cos 0 value 1. Okay, students. So finally, what is that here? E net is equal to k lambda by r. Minus into minus plus 1 plus 1. What is also finally? E net is equal to, therefore, E net is equal to 1 plus 1, 2. 2k lambda by r. Okay, students, E net is equal to 2k lambda by r. Therefore, finally, right now, E net is equal to 2k lambda by r. Okay, students, this is very important to find the electric field intensity due to the charge distribution bodies. Okay, next class we will discuss the another points, another important concept and problems we will discuss. Okay, bye.